Okay, so can I tell you something? This just clicked for me. The observable universe has an edge, and we're not going to see past it. Like, never. Not eventually. Not with better technology. Never. And it kind of changes nothing, but also everything at the same time. Hi, I'm Lilith. If you like me somehow never connected these dots before, welcome, you're not alone. And if you have no idea what the observable universe even is, honestly, even better, you're exactly where you have to be. So let's start with us. We are living on a rock flying through space at the speed of 107,000 kilometers per hour. You cannot feel it, but you're moving.
Our rock, Earth, is orbiting a star, the Sun, which sounds ordinary until you learn that more than 1 million Earths could fit inside it.
And even that is considered pretty average as stars go.
There are stars so large that if you put one where our Sun is, it would swallow Jupiter entirely. Betelgeuse, the bright red star in Orion's shoulder that you can see on any clear night, would do exactly that.
Average. Our Sun is average. Now let us zoom out a little.
The Sun sits inside a solar system. 8 planets, hundreds of moons, millions of asteroids. Comets travel so far out that they take thousands of years to complete a single orbit. And the distances between things in our solar system alone is already hard to hold in your head. Light, the fastest thing in the universe, takes 8 minutes to travel from the Sun to Earth, and 4 hours to reach Neptune.
All this is already fascinating, but that's just our solar system. So, zoom out more.
There are somewhere between 100 and 400 billion stars in the Milky Way. We don't know the exact number, which I find kind of incredible. Our own galaxy, and we can't even count what's in it. A spiral, 100,000 light years across, and we are nowhere near the center. We sit about 26,000 light years out.
Which turns out to be a pretty good neighborhood, actually. Far enough from the dangerous, dense, chaotic core. Close enough to be part of the whole structure. We orbit that center. Our entire solar system is moving together at 720,000 kilometers per hour. Once every 225 million years.
The last time Earth was in this exact position in its orbit around the galaxy, dinosaurs didn't exist yet. Pangaea was still one continent. The first mammals were just beginning to appear. The asteroid that would eventually end the age of dinosaurs was still 160 million years in the future.
That was 1 galactic year ago. And in that entire time, we did a full circle around something we photographed for the first time in 2022.
Sagittarius A, a supermassive black hole, 4 million times the mass of our Sun, gravitational heart of our galaxy. Every single star in the Milky Way orbits it.
And we have a photo of it. It's a big deal, actually. Black holes don't emit light. So what we captured is the shadow they cast against the light around them.
The Milky Way is not alone. Together with Andromeda, the closest to us, and about 50 smaller galaxies, they are called the local group.
Our little corner, which sits inside something bigger. Laniakea Supercluster.
A gravitationally bound structure containing roughly 100,000 galaxies, 500 million light-years across. Our entire local group is a tiny little cluster on the outer edge of it, like a small village on the outskirts of a continent.
And we only discovered that we live inside it in 2014.
Not because it was faint or far away, it was always there. And we had an idea of it in the 1980s. We just couldn't map it, because mapping the motion of hundreds of thousands of galaxies precisely enough to identify the gravitational boundaries of a structure that large required data and computing power we simply didn't have before then.
And the thing is, if we only found Laniakea 12 years ago, what else are we inside right now that we haven't mapped yet? What are we part of that we don't have a name for? What is Laniakea itself flowing into that we haven't found yet? And the answer is, we don't know. The map keeps getting bigger every single time we look.
And all of Laniakea, every single one of those 100,000 galaxies is moving, streaming, flowing together in the same direction, toward something.
That something has a gravitational pull of tens of thousands of galaxies, pulling everything towards it at hundreds of kilometers per second, including us right now, as you watch this video. And it started before humans existed, before Earth existed, and even before our sun ignited.
We call it the Great Attractor. And we cannot see it clearly, not because it's dark or tiny, not because our telescopes aren't powerful enough, because it's hiding behind our own galaxy, behind thousands of light years of dust and stars, so dense that optical light, almost anything visible, can't get through. We call this region the zone of avoidance, a band across our sky where our own galaxy is so thick, so dense, that almost nothing behind it gets through to our eyes. The thing pulling everything we know toward it is hidden behind our own home.
We only found it because we noticed everything was moving wrong. Galaxies that should have been drifting with the general expansion of the universe weren't. They were streaming, converging like water going down the drain. When astronomers traced those streams backwards, they all pointed to the same place. And then, just when you think, okay, that's the biggest thing, it turns out the Great Attractor itself is also being pulled towards something even larger.
The Shapley Supercluster, one of the most massive concentrations of matter in the entire observable universe. So large that even the Great Attractor, this thing pulling roughly 100,000 galaxies, is basically just a tributary flowing into it. Everything is pulling everything, in a chain so large we're only just beginning to trace it, and we still don't know where the chain ends.
Now I want to stop zooming out for a second, because there is something about all of this that I think deserves more time. When you look up at the night sky, you are not seeing space. No, you're seeing time.
Every single point of light in the sky left its source at a different moment in the past. Some of them hundreds of years ago, some thousands, some millions. All of those completely different moments arriving at your eyes at the same time. The night sky is not a snapshot of right now, it is a collage. 1,000 different moments in history are displayed simultaneously.
And some of those stars are already dead. They burned out, collapsed, exploded years ago, some decades ago, thousands of years ago, and we're still seeing them as they were when they were alive, because the light from their death hasn't reached us yet.
Betelgeuse is about 650 light years away. In 2019 and 2020, it dimmed dramatically, unexpectedly, in a way astronomers had never observed before. There was a genuine scientific discussion about whether it was about to go supernova, explode, die.
Turns out it was just a massive dust ejection. A stellar sneeze, if you wish, but if it had exploded, we would have been watching something that happened in the 14th century. And the light from that explosion would only be reaching us now.
The most distant galaxy James Webb Space Telescope has ever photographed, the MOM Z14, is 13.5 billion light-years away, meaning that we see it as it was just 280 million years after the Big Bang.
That galaxy has probably merged with others since then. Its stars have been born and died, many generations of them. It may look nothing like what we see, but the information hasn't arrived yet, because on a cosmic scale, even light takes time. So when people ask what's out there right now, the honest answer is, once again, we genuinely don't know. We only know what was out there millions of years ago, billions of years ago. The universe we observe is a museum of past, and the present, the actual right now of the universe, is hidden from us, everywhere and always. Which brings me to Hubble, and one of the most extraordinary moments in the history of science.
In 1995, just 1 year after I was born, scientists pointed the Hubble Space Telescope at a patch of sky near the Big Dipper, a patch that appeared completely empty. No stars, no galaxies, nothing visible, just blank darkness. And they kept it pointed there for 10 days. What came back changed everything we thought we knew about the universe. 3,000 galaxies. Not stars, galaxies. Each one contains hundreds of billions of stars. In a patch of sky the size of a grain of sand held at arm's length.
If that one patch of empty sky contained 3,000 galaxies, and the sky contains approximately 12.7 million similar patches, there are approximately 2 trillion galaxies in the observable universe. Not a billion, trillion. We didn't know that before 1995. We thought the number was in the billions. 10 days of exposure aimed at nothing. One photograph and our estimate of the number of galaxies in the universe went up by a factor of 10.
They did it again in 2004. Longer exposure, smaller patch. The Hubble Ultra Deep Field, 10,000 galaxies. Some of them were so distant their light had been traveling for 13 billion years to reach the camera. The most distant objects ever photographed at that point. Light that left its source when the universe was less than 800 million years old. Starting from 2022, the James Webb Space Telescope is looking even deeper. It doesn't see light the way your eyes do. It sees in infrared, wavelengths too long for humans to detect, but which carry something ordinary light cannot. The signal of very early universe. As the universe expands, light from the most distant galaxies gets stretched. Visible light shifts into infrared. So the further back you want to look, the more you need a telescope that can see what our eyes cannot. And we got this. The first deep field image from the most powerful infrared telescope we have ever built. Galaxies from 300 million years after the Big Bang. Clearer than anything Hubble could produce. Colors that encode billions of years of cosmic history, colors we assigned to light we were never meant to see. And in that image, galaxies that looked wrong. Too large, too bright, too developed for how early they were. Galaxies that, according to our models, shouldn't have existed yet. Galaxies that the universe hadn't had enough time to build.
Our models were wrong. The entire universe was more active, more structured, more developed than we thought. We love to underestimate, And this keeps happening. Every single time we build a better telescope and point it deeper, we find something that rewrites what we thought we knew. Every time, without exception.
In 1929, astronomer Edwin Hubble discovered the cosmic expansion. He noticed that the farther away a galaxy is from Earth, the faster it appears to be receding from us.
That was very symbolic to measure the expansion discovered by Edwin Hubble with a telescope named after him. Also, it raised new questions.
Using a type of star called a Cepheid variable as a measuring rod, astronomers got one number. When cosmologists calculated the expansion rate from the cosmic microwave background, the leftover glow from the Big Bang, they got a different number.
Not slightly different, significantly different. Both measurements are precise. Both teams have checked their work obsessively. Both numbers are right, according to their own methods, but they are different.
This is called the Hubble Tension, and it has been one of the most discussed and debated problems in cosmology for over a decade. Because if both measurements are correct, something is missing from our understanding of the universe. Some physics we don't know about yet. A crack in the model.
James Webb Space Telescope has been measuring it too. The tension isn't going away. If anything, it's getting sharper. We built the most precise instruments in the human history, pointed them at the universe, and found that our best model of how everything works has a hole in it.
The observable universe, 93 billion light-years across. Not the universe, but our window into it. The region where light has had time to reach us in 13.8 billion years of cosmic history. Within it are 2 trillion galaxies, 1 septillion stars, a 1 followed by 24 zeros.
And beyond the edge of that window, more universe, possibly infinite. I mentioned in the beginning that light is the fastest thing in the universe. But the regions beyond our observable edge are moving away from us, faster than light can travel between us. Not because they're moving through space, but because space itself is expanding. They're not temporarily out of reach, they're permanently out of reach. That's why we'll probably never be able to know what is behind that edge.
Physics drew that line. Not our budget, not our technology, not our cleverness. The structure of space-time itself says this far and no further. So that's where we are. One planet, one star, one galaxy among 2 trillion. Inside a supercluster we only named lately. Being pulled towards something invisible we still cannot see. Looking at the sky that shows us the past but never the present. Surrounded by an unknown that may be infinite.
We're made of atoms forged in stellar explosions, living on a rock hurtling through a supercluster towards something invisible. Looking at the night sky that shows us light from before our species existed. Finding cracks in our best models every time we built a better telescope. And still curious enough to point a telescope at empty darkness and wait. And I think that's the best and most extraordinary thing of all. Thank you for your time. See you in the next video.